Hi, welcome to Algebra 2 Common Core. Today we're going to continue our work with rational expressions by looking at how we can simplify rational expressions. In example number 1, we're going to go back to a nice easy example, one that would have been a middle school example. When I look at the fraction 18/12 and I want to simplify this, you'll recall that what we did was look for the greatest common factor of both the numerator and the denominator. So I see that 18 and 12 can both be divided by the same factor of 6. So I'm going to divide the top and the bottom by 6. And I end up with 3/2. So really what I had to do there was factor the 18, factor the 12, and find a factor that was the same so that I could cancel in the numerator and the denominator. Let's apply the same principle in part B when I'm simplifying this algebraic fraction. So in the numerator, x squared minus 9, I can factor that into x plus 3 times x minus 3. My denominator can be factored. 2x plus 6 would be 2 times x plus 3. So just like our previous example, when I see a like factor in the numerator and the denominator, I can cancel off the factor of x plus 3 from both. So that's leaving me with an equivalent fraction of x minus 3/2. Now it's important to note what the process is giving us here. In our original fraction, no matter what x value I put in, if I then substitute the same x value into my new fraction, both fractions should have the same value. Let's try a number and see if that works. What if we say let's let x equal 4? In the original problem, x squared minus 9, that would give me 16 minus 9 over 2 times 4 plus 6. So that fraction would be 7/14, which reduces to 1/2. Now what should happen is when I substitute 4 into my newly simplified answer, when I substitute 4 in for x, I'm getting 4 minus 3 divided by 2, and I see that the value of this fraction has stayed exactly the same. The value is still 1/2. This would work no matter what value of x I used. My original fraction and my simplified fraction should have exactly the same value. Now, I'd like you to pause the video for a few minutes and copy down the instructions for the box. To simplify a rational expression, if my numerator and denominator have polynomials, then what I need to do is factor the polynomials first. We've had a lot of practice with factoring in this course, so that should be something that should be a good review for us. If I have a monomial in the numerator and or the denominator, then I don't do any factoring. In step 2, I'm going to cancel any factors that are alike in the numerator and the denominator. And as you saw in example B above, I can always try a value of x and be sure that when I substitute the value of x into the original and into the newly simplified fraction, I should have exactly the same value. So let's look at some examples in exercise number 2. You'll notice that in part A I have a monomial over a monomial. What that means is that I don't need to factor like I do with polynomials. It might be helpful for the first example or two for you to write out all of the factors of each monomial. So in the numerator I have 3, I have 5 factors of x, and I have 6 factors of y. In the denominator I have a 6, I have 8 factors of x, and I have 3 factors of y. So what we can do when I've factored out each monomial is cancel any factors that match. 3 and 6 can both be divided by 3. So 3 divided by 3 is 1, 6 divided by 3 gives me 2. Every time I have a factor of x in the numerator, it can cancel with a factor of x in the denominator. So I'm going to go along and cancel like factors in the numerator and the denominator. Could we also use our rules for exponents like we did in the last chapter? Yes, of course. In the numerator, I also see that I have like factors of y, so those will cancel as well. Every time I'm doing a cancellation, I'm really dividing both the numerator and the denominator by the same factor, leaving me with a 1 on the top and the bottom. So my final answer here, in the numerator I have 1y to the third, and the denominator I have 2x to the third. So my complete solution in factored form, in simplified form is 1y cubed over 2x cubed. Let's try b without writing out all of the factors, because I see that I've got 10 factors of x and 8 factors of y. I'm going to cancel. The 20 and the 4 can both be divided by 4. So I'm going to get a 5 over a 1, but of course I don't have to write that 1. In the numerator I have x to the 10th, in the denominator x to the 2nd. So when I'm dividing, I subtract exponents. Last, I'm going to look at the y. I don't have anything to divide the y by, so that's going to be a y to the 8th. So here is my simplified rational expression. For part C, 7 and 21 can both be divided by 7, so that's going to leave me with a 1 on top and a 3 on the bottom. X to the third on top and x to the 5th on the bottom. I can think of this as 2 extra factors of x on the bottom, or I could also do the division by subtracting exponents. 3 minus 5 gives me negative 2, but x to the negative 2 in the numerator would move to the denominator as an x squared. Likewise with the y, I've only got 1 factor of y on top, but I have 8 factors of y on the bottom. So if I cancel that 1 like factor, I'm going to end up with a y to the 7th on the bottom. I've canceled everything off of the numerator, so that tells me that my numerator is left with a 1. Don't forget to fill that in. Pause the video for a minute and please try the you try it. This is a multiple choice you try it, so see which answer you're going to pick. I did some cancellation with the numerator and the denominator wherever I had like factors. So 10 and 15 could both be divided by 5, so that gave me 2 over 3. X to the 6th divided by x to the 2nd is x to the 4th. And when I've got a y to the 3rd in the numerator, but a y to the 6th in the denominator, there's 3 extra factors of y in the denominator. So my final answer is choice 3. Now let's move on to some rational expressions where I have polynomials in the numerator and the denominator. So for example number 3, I've got x squared plus 5x minus 14 over x squared minus 4. So let's factor my numerator. So I'm going to say x plus 7 times x minus 2 would be the factors of the numerator. The denominator is the difference of 2 perfect squares, so I'm going to factor that into x plus 2 times x minus 2. I do have like factors. X minus 2 cancels with x minus 2, and I'm left with x plus 7 over x plus 2. I'm going to encourage you to check each of your answers like we did on the first example. So select any value of x. In this case, I'm going to pick x equals 5, and I'm going to see if this gives me the same value in both the original expression and the newly simplified expression. So in my original, I'm getting 25 plus 25 minus 14. That, of course, is 36. And the denominator, I'm getting 25 minus 4, which is 21. and that reduces to 12 over 7. Now let's put that very same value of x equals 5, into my simplified answer to see if they have the same value. So at x equals 5, I'm going to have 5 plus 7 over 5 plus 2, which also gives me an answer of 12 sevenths. So I'm fairly confident then that these two expressions are equal to each other no matter what my value for x. So my simplified answer, x plus 7 over x plus 2. Let's try b. 4x squared minus 1 would be factored into 2x plus 1 times 2x minus 1. For the denominator, I can take out a GCF of 5, and that leaves me with 2x minus 1. Now, when I have exactly the same factor in the numerator and the denominator, I can cancel those off, and my simplified fraction would be 2x plus 1 over 5. And again, our goal is to find an expression that has the same value, but it's in a simpler form because it doesn't include common factors in the numerator and denominator. Let's look at C. In my numerator, I'm going to go ahead and use the box to factor. So I have a 3x squared. I have a positive 8. My multiply is equal to 24. And my add is equal to 14. So that's telling me, let's see here, I'm thinking 12x and 2x should fit the bill. In the top row, I'm going to take out a 3x. In the bottom row, I'm going to take out a 2. In the first column, they have an x in common. The second column has a 4 in common. So 3x plus 2 times x plus 4. The denominator can be factored into x plus 4 times x minus 4. That allows us to cancel off my like factors of x plus 4. So my reduced or simplified fraction should be 3x plus 2 over x minus 4. And again, I could pick a value for x and see if they match. There's a special type of simplifying that occurs whenever we have expressions in the numerator and the denominator that are in the form of x minus y and y minus x. Let's try some easier examples first and see how this is going to work out. So if I've got 9 minus 6 in the numerator, 9 minus 6 is of course equal to 3. In the denominator, I've got 6 minus 9, that's equal to negative 3. So 3 divided by negative 3 is negative 1. Same with b. I'm getting a 12 in the numerator, a negative 12 in the denominator, and when I divide those, I also get negative 1. So we can take a look at c, which is in terms of variables. In the numerator, I've got a minus b. In the denominator, I can factor out a negative 1, and I would be left with a minus b. So the a minus b's could cancel, and when I do that division, I'm getting a negative 1. So in conclusion, what we can say is that whenever factors of the form x minus y and y minus x are involved, we can cancel and are left with negative 1. We'll see some more examples of that in a few minutes. Now I apologize, exercise number 5, I inadvertently copied the same two first examples. So we're going to cross those two off, and instead I'm going to replace them with a different example that we're going to do together. So fit this where you can. If you can just cross off A and B and then rewrite this new example. My new example is going to be 12 minus 3x over x squared minus 2x minus 8. So both the numerator and the denominator have polynomials, so I'm going to factor. In the numerator, there's going to be a GCF of 3, so that leaves me with 4 minus x. In the denominator, I'm going to factor this trinomial, and I'm going to get an x times x, then a minus 4, and a plus 2. So here you see we have this example of in the numerator 4 minus x, and in the denominator x minus 4. These are sometimes called opposite factors. So when I cancel them off, I can cancel these opposite factors as long as I remember to multiply in with a negative 1. So in the numerator, I'm getting an answer of negative 3. In the denominator, x plus 2. Example 5, part C is slightly different, so let's go ahead and work on that one. 4x squared minus 1, that factors into 2x plus 1 times 2x minus 1. In the denominator, 4x minus 2, I'm going to factor out a GCF of 2, and I'm left with 2x minus 1. Again, I see that I have like factors in the numerator and the denominator, so I can cancel those off. And this solution is going to be 2x plus 1 over 2. So this will be my simplified fraction. Now I'd like you to try the 2 U-triads that follow, and then come back and see if our answers match. Looking at the first U-triad, I factored 2x minus 10 into 2 times x minus 5. The denominator is going to be 5 plus x times 5 minus x. So the numerator and the denominator have opposite factors, x minus 5 and 5 minus x. So when I canceled those two factors, I had to include a negative 1. So 2 times negative 1 gives me a negative 2. In the denominator, 5 plus x means exactly the same thing as x plus 5. So I'm choosing multiple choice number 1. For the second one, I factored the numerator into x minus 3 times x minus 3. The denominator, I used a greatest common factor of 6, and I was left with 3 minus x. So I'm going to cancel off 1x minus 3 with a 3 minus x in the denominator. They're opposites of each other, so I'm going to keep the negative 1. Now I've got a couple different options for how I should write this answer. I can either take the negative 1 and distribute it through the numerator, in which case I'd have negative x plus 3 over positive 6. Now I could reverse my terms in the numerator, so that could also be written as 3 minus x over 6. I could also just take the negative sign and put it in front of the whole fraction. So I could say negative of x minus 3 over 6, and that would be equivalent as well. So when I look at my choices, I am going to pick choice 4, which matches this solution right here. Thanks for working with me on simplifying rational expressions, and we'll see you tomorrow. Have a great night.